All right, so as we've discovered in our Desmos activity, derivatives of polynomials end up having the form of another polynomial that's 1 degree lower. We can generalize this by saying functions of the form ax to the n, where a and n are elements of reals, so functions, not polynomials. So if we said polynomials, then n would be positive integers. But saying a and n are element of reals, we can expand this to say that the derivative function is decrease the power by 1 and multiply the constant or the coefficient by whatever the original power was. So here's our new notation for the derivative. So we're going to remember that f prime of x is the same as dy of dx is the same as m being the slope of the tangent. So this comes from first principles, and it's true for any function that has a power. So remember, in the last set of notes, we saw that if f of x is root x, then the derivative function at any point a was 1 over 2 root a. Well, this is the same as 1 over 2 a to the half power, which is the same as 1/2 a to the negative half. Remember, this is the same as x to the half. So if we just wanted f of x, remember we're replacing a with x, I bring my power in front, multiply it by 1, there's my half, decrease this by 1, and I get negative half. So this rule, going from this to this, works for any power. If I come to my formula booklet, let's go to page, 18 or so. That's not the formula booklet. Let's see here. All right, so now let's come to page, let's say 12. All right, a little bit too far. So we've got derivatives. Here's our very first derivative given in the formula booklet is the power rule. So coming back, we can use this. So if I think about a constant, think about the graph of a constant. Of course, the graph of a constant is a horizontal line at C. So if I put in this horizontal line, at any point, the slope is 0. If I have a power, the derivative is n times x to the n minus 1. If I have a constant in front, I can just say that, so if f of x is some constant times g of x, then the derivative of f of x is that constant times the derivative of g of x. So the constant is going to stay there. If my function is the sum of two functions, the derivative is just the sum of the derivatives. Sum or difference doesn't matter. So here, I'm going to have derivative of g minus derivative of h. So those are some basic rules. We're going to come back in the next video and apply it to these functions.